Hello, in this video we're going to be graphing linear equations, but this time we're going to be doing it when the pattern doesn't necessarily match. So it might not be written in the form y equals mx plus b. Before watching this video you really should be familiar with graphing regular linear equations, that is, equations that look like, say, y equals 2x plus 3. Again, the 2 is the slope, the plus 3 is the y-intercept. We're not going to be covering these equations in this video. That's an introductory video that you should watch first. What we need to do is consider equations that don't necessarily match the pattern. And there's just a couple rules that you need to remember. You can always add 0, and whenever you add 0, you do not change the actual equation. You can also multiply by a form of 1. And when I say multiply by a form of 1, that means you can always multiply by, say, 1 over 1. And again, you will not change the equation. So in each case that we do below, with one exception, we're going to try to force the equation to look like y equals mx plus b. And again, m is the slope, and then the plus b part is the y-intercept. So let's take a look at our first example. In this case it says y equals x plus 3, and if you look at it, there doesn't seem to be an m. So what we're going to do is we're going to force there to be an m, and we're going to do that by multiplying by 1. And we're going to multiply by a form of 1. So we're going to say y equals 1 over 1 x plus 3. Now you don't have to actually write this down, but for the first few examples you might want to just make it a good habit. So then the slope is really rise 1, run 1. So we start here at plus 3, the y-intercept is plus 3, and we're going to rise 1, run 1. And then so this is going to be our line. So then we just sketch that in. Now the next example is going to be y equals negative x plus 4. Now again, there doesn't seem to be a number here, but what would that number be if you were to force there to be a number as a coefficient of x? That would probably look something like this. Y equals negative 1 over 1 x plus 4. And again, we're forcing there to be a coefficient, but we're really not mathematically changing anything. We're just multiplying by a form of 1. In this case, we're multiplying by a form of negative 1. This equation is mathematically the same thing. So again, we're going to rise 4, there's our y-intercept, and our slope is rise negative 1, run 1. So we go down and to the right. And then so we just plot a series of points, and we can go backwards, and then we can graph the line, sketch a line between these points. Now again, if you had a straight edge, your line would be more straight than mine. How about this next one? Y equals negative 2. Again, we're going to try to force it to be in the form y equals mx plus b. But I don't see any x value. So what can we use for the m so that it would not change the equation? And again, remember what we said about multiplying by 0. If you multiply by 0, you really haven't changed anything. So our equation can actually be y equals 0x minus 2. So this minus 2 is really our y-intercept. And what is our slope? Our slope is 0. And how can we rewrite the slope? So that it's a fraction. We can rewrite that as 0 over 1. So our new equation is y equals 0 over 1x minus 2. So our y-intercept is negative 2. And our slope is 0 over 1, which means we rise 0, run 1. Rise 0, 1 run. Rise 0, 1, 1. Run 1. And I hope you can see that this is going to be a horizontal line. So we can just sketch that line in here. So it's going to be a horizontal line at y equals negative 2. Now let's take a look at a couple more examples. How about this one? Y equals 2/3 x. again, we want it to be in the form of y equals mx plus b, but there is no plus b in this case, so we're going to add 0. We're going to add 0, so therefore our y-intercept is actually 0. So we can graph that right here at the origin. Our y-intercept is 0, and then we're going to rise 2, run 3. Rise 2, run 3. We can go backwards. Rise -2, run -3. And then we can sketch our line. Now this last one does not match the pattern y equals mx plus b. And there's no way it can. There is no way we can solve this equation x equals 3 for y. So this is a special equation, in which case there is the slope is actually undefined because you literally cannot solve this equation for y. So we just consider logically, what does this mean? X equals 3. Well, over here is the x-axis, and over here is the y-axis. Well, x equals 3 looks like this, but it's not just a dot, it is every point where x equals 3. I can go up, I can go down, I can be right on the axis. X equals 3 everywhere, and y can equal any number at all because y really isn't defined in this equation. So if we were to sketch that line, it's going to be a vertical line at x equals 3. So that's really a special form because it really does not match the pattern y equals mx plus b. So to recap, if it doesn't match the pattern, you can force it to match the pattern. For example, by multiplying by 1, which means our slope is 1, or maybe our slope is -1 in the second example, or we can actually add 0. You're always allowed to add 0 without changing the value. Here we added 0 times x. And in the second to last example, we added 0 for the y-intercept. And the final example, we really could not solve for y. So we just had to use logic to make a vertical line at x equals 3.